Following up from Imagination's announcement during the last RISC-V summit, we are launching today the first member of our Catapult CPU family, a real-time embedded CPU. This CPU is a highly competitive and very efficient implementation that has a wide range of applications, especially around in the embedded space, around smart metering applications or SoC helper cores for networking or packet management or storage control.
So there's been a real buzz around RISC-V recently, and there have been a lot of CPU releases, open source, closed source. I think what sets Catapult apart from all of these is that it's actually addressing what I think has been a huge gap in the RISC-V market, which is a core that's just really solid. It's a professional core. It offers the performance and the efficiency that people would actually expect from a commercial offering. That's really what Catapult is. It's grown up RISC-V.
I think what excites me about this CPU is partly just how capable it is for an initial offering in the Catapult family, but also it's great to see everyone's hard work come to fruition, and it's great to see the CPU get into partners' hands as well. So until now it's been a name on a slide, but now we're actually able to engage with partners on a whole new level, and they're able to see that there's been some real high quality engineering going on behind the scenes. I mean, to be honest, it's not so much this launch that excites me, it's what's coming next. This is the most configurable and flexible code base I've ever seen, and we're ready to push it in all sorts of different directions.
The RISC-V ISA is a new ISA. It doesn't carry any legacy from old architectures of the past. And at the same time, the Catapult design itself is a new design. It's from scratch. There's no legacy in the code base. There's no dead weight. So it's a really efficient design.
So personally, I'm focused on the multi-core aspects of the Catapult family, and we're looking at making that the most sort of extensible, flexible, configurable, scalable memory system to really match the characteristics of the CPU cores themselves. So we're working on 64-bit vector processing, multi-core, all the sorts of things that you'd hope Imagination was working on, and also looking at how we can make things easier for our partners as well, how we can deliver them lots of different Imagination IP and make integration as straightforward as possible so that they can get the most out of their systems, essentially. I think what's really important in CPU development is keeping interoperability in mind from the outset, second only to sort of making sure that we maintain that high quality that Imagination is known for. And I don't mean I don't just mean interoperability between different cores. I mean different interoperability between different processor IP as well. So workloads today, they don't just fit on one type of processor. You need CPUs, GPUs, AI accelerators to really get the most out of your system. And this is where Imagination really stands out in the industry, I think. We've got all those different building blocks, and building the hardware interaction and the software story around the GPUs, CPUs and AI accelerators, that's going to put Imagination at the forefront of of heterogeneous compute for many years to come.